And here we are with our second video about angles. In angles part one, we named angles, we classified angles, and we discussed complementary and supplementary angles. And in this video, we're going to look at a few more relationships that we might see when two lines intersect and different angles are formed. So the first one we're going to look at here, vertical angles. And vertical angles are simply two angles whose sides form two lines. And it's also important to mention that vertical angles are congruent. So here I have a green line and an orange line that are intersecting, and that forms angle 1, angle 2, and angle 3, and angle 4. And what's happening here is angle 1 and angle 3 are vertical angles. Let's get the highlighter out and let me kind of show you here. Here's angle 1. It's made up of the orange and the green. And likewise, angle 3 is made up the rest of the orange and the rest of the green lines. Angle 1 and angle 3 have no sides in common, but they do have a vertex in common. So we can say that angle 1 and angle 3 are vertical, and we can also say angle 1 and 3 are congruent. So we would say angle 1 and 3, and we would also state that angle 2 is congruent to angle 4. Now it's important for me to mention to you, we also have other relationships here. Because that orange is a line, it's also a straight angle. So for example, what if I were to say that angle 2 measures 30 degrees? Well, from that one angle, you could find the measure of angle 1, angle 3, and angle 4. Now, obviously, because 2 and 4 are congruent, we know that angle 4 would also be 30 degrees. But what you may not see right away is angles 1 and 2. I didn't mean to mark that off there. That's 30. Those are supplementary because of that straight angle. So 180 minus 30 makes angle 1 150 degrees. And since angle 1 and 3 are vertical, angle 3 is also 150. But we could also even notice that angle 3 and 4 are also supplementary. So there's lots of relationships going here. Happens even more so when we have two parallel lines cut by a transversal. So here my two black lines are parallel. Now they're technically not parallel. I need to use this little symbol. So I'm going to put these little parallel symbols. Now we definitely know they're parallel. That red line is intersecting both of them, and we call that a transversal. So let's just call the transversal T, and then maybe I'll call this line right here angle L and angle P. So it's very important that you know that your two lines that are cut by the transversal are parallel. Otherwise, you won't have all the congruent angles and such. All right, so let's put some numbers on here. Here, let's call this 1, 2, 3, and angle 4, angle 5, angle 6, angle 7, and angle 8. Okay, let's talk about just interior and exterior angles first. I'm going to highlight some stuff and then I'm going to erase it. But right in here, angle 3, 4, 5, and 6, we call those interior angles because they're in between lines L and P. Okay? Likewise, 1, 2, and 7 and 8 are exterior angles because they're on the outsides of lines L and P. All right, so that's kind of pretty general. Now we also have some vertical angles. 2 and 3 are vertical, 1 and 4 are vertical. Then down here, 5 and 8 are vertical, and 6 and 7. Now, some new angle relationships that we might see. Corresponding angles. Corresponding angles, let's put a bullet there, lie in the same position. Okay, the angles that are corresponding. This is my symbol for angles. It's an angle sign with an S instead of writing it all out. So my corresponding angles here are angle 1 and 5, because they're both on the top of their lines and they're on the left of the transversal. What you could also do is think about, okay, well, what if I picked up line L and set it right on top of line P? Then 1 and 5 would sit on top of each other. And angle 2 and angle 6 and angle 3 and 7 and angle 4 and angle 8. Those are corresponding, and corresponding angles are also going to be congruent. So 1 and 5 are congruent, 2 and 6, 3 and 7, and 4 and 8 are also congruent. All right, we also have something called alternate. So think about what that word means. Alternate interior angles. And they are also congruent. All right, so they have to be interior, so that means 3, 4, 5, and 6. And the word alternate means opposite sides of the transversal. So my alternate interior angles are 3 and 6. So we can say 3 is congruent to 6. And 4 and 5. See how they cross over the red line, the transversal? So angle 4 is congruent to angle 5. Well, we have alternate interior angles, so we have to have some alternate exterior angles. And it's the same idea, alternate exterior angles, and they're also congruent. So my alternate exterior angles would be 1 and 8, because they're exterior, meaning they're on the outside of the parallel lines, and then alternate, meaning they're on opposite sides of the transversal. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Those are really common, as well as the vertical angles, and I do want to mention two more. You might have same side interior angles, and they are supplementary. Okay, so they are not congruent, they're supplementary. Same side interior angles would be 3 and 5. So we could say angle 3 plus angle 5 is 180. And my other pair of same side interior are angle 4 and angle 6. So angle 4 plus angle 6 is equal to 180. And lastly, because we had same side interior, we also have to have same side exterior. And those are also supplementary. And that would be angle 1 and 7, you guessed it. Angle 1 and 7, oops, forgot my symbol. And angle 2 and angle 8, because they are on the outside, that makes them exterior, and they're on the same side. Okay, so those are the only two types that are not congruent, they're supplementary. So using all these different relationships, I can give you a picture that looks like this and one angle measure, and we can find all the other angles. So let's try that now. We can use any of this information to figure this out. All right, so this time we have two parallel lines that are purple. Okay, I didn't mark them as parallel, so let's just mark them. Okay. These relationships of congruency, or if they're supplementary, it only holds true if the two lines are parallel, which is probably what you'll see. Otherwise, you can't get any measures out of the deal. All right, and the red line is the transversal, because transversal just means it's cutting the lines. They give us, if the measure of angle 2 is equal to 120 degrees, find the measures of the remaining angles. So the first thing I would do is I would put 120 degrees right here on angle 2. Now, a couple of things we can do here. First of all, 1 and 2 are supplementary. That's one of the first words we learned in the previous video, because that's a straight angle. So if they're supplementary, All we have to do here is say 180 minus 120, and that makes it 60 degrees. So angle 1 would be 60 degrees. Now we can also use the idea that 2 and 3 are vertical, and vertical angles are congruent, so angle 3 is 120 degrees. Well, 1 and 3 are also supplementary, so I feel pretty confident about our answer for angle 1, and 1 and 4 are vertical, so we can say that that's 60 degrees. All right, now we also know about same side interior, or we know about alternate interior. I kind of like alternate interior because they're congruent, so I don't really have to spend time adding and subtracting. So I know that angle 4, let's see if we can get the highlighter here. Here's angle 4 and angle 5. Those are in between the purple lines and they're on opposite sides of the transversal. So that makes those two alternate interior. So angle 5 is 60 degrees. And 3 and 6 are also alternate interior, so that's 120 degrees. Now we can go a couple of different routes here, guys. We can just use the idea 5 and 8 are vertical, or we could also say 1, here's angle 1, and 8 are alternate exterior. Lots of ways to look at it. Now that you know all these classifications, there's so many different ways to find the answer. Regardless, it's 60 degrees. And 6 and 7 are vertical, so it's 120 degrees. And I just want to point out, because we didn't talk about it a lot on the last slide, but I would like to go ahead and point out that angle 3 and angle 5 are the same, they're on the same side as the transversal, and they're interior, and they're supplementary. 120 plus 60 is 180. So all these relationships hold true, so we have found all the measures of all the angles just given this one measure at the beginning.